Let's talk about projectile motion. Well, a projectile is an object which is thrown into air and moves. This is an object, let me write here, thrown into air and moves in the influence of gravity, moves under the influence of gravity, under the influence of gravity. Okay. So, for simplicity, we can neglect the air resistance. Air resistance can be neglected here. This is for simplicity. Well, if you note it carefully, then you will realize that projectile motion is a motion in two dimensions or motion in a plane. Well, how we deal with this, that we try to analyze the motion in two axes. That means we try to analyze the motion horizontally and also vertically, and we deal with this motion one by one so that it becomes pretty easy. So, now let me just draw the simple diagram. Suppose this is x-axis and this is y-axis. So, we can say that this is horizontal axis or x-axis and this is vertical axis or y-axis, and this is the starting point. So, a projectile goes like this, attains a maximum height, and after that it comes down. Well, if you see that we are throwing this projectile with some velocity, and I can draw this velocity like this. So, this is velocity and initial velocity, and can define this initial velocity as let me say V naught. Now, this is making an angle theta with the x-axis. So, first of all, let me define this angle theta. This angle theta, I think I can write here, is angle of projection. Angle of projection. Well, this angle theta will have two components, and here this is one component is V cos theta, and this vertical component, or sorry, we can say V naught, because initial velocity is V naught, and the vertical component is V naught sin theta. Well, the horizontal range achieved by the projectile is given by r, and this is this distance, horizontal distance. The maximum height achieved by the projectile is given by this h. Now, let us discuss the path of the projectile. Let me just write here, path of projectile. So, we need to analyze what kind of path a projectile has to follow. So, here in this, let's consider the horizontal component, and we know that horizontal component is V naught cos theta. So, well, one more aspect, there is a acceleration here, an acceleration due to gravity, and it is acting vertically downward. So, we have equation which says S is equal to V naught t plus half a t square. Now, we need to apply this equation for horizontal direction, for horizontal component. Well, in the horizontal component, so the displacement we can call it x, and this V naught actually is V naught cos theta, and this is t. And in horizontal direction, we know that acceleration in horizontal direction is going to be 0. Why? Because there is only one acceleration which is acting vertically downward, that is acceleration due to gravity. So this is 0. Now we can write x is equal to v naught cos theta t, and this is equation 1. Similarly, we shall use the same equation for vertical moment. So in vertical moment, this x instead of s we can write y, and in vertical moment we can write this v naught sine theta, and this is t. Now a y is minus g. Why? Because g is acting vertically downward, and we are using the sign convention. The below direction, downward direction is negative, and the upward direction we take as positive. That is the sign convention we are using. So let me use this convention: v naught sine theta minus half a. Instead of a, we can write g, and this is t square. Well, let me just rub this little bit, and here I can write it. The vertical component of acceleration is a is equal to minus g. Now this is equation 2. Now from equation 1 and 2, what we can do, I can eliminate t, and we can eliminate t by just putting the value of t. T is equal to x upon v naught cos theta. This is the value from 1, and then put this value in 2. So y is equal to v naught sine theta and x upon v naught cos theta minus, and then half g, and t square means x upon v naught cos theta square. Now if we just simplify, what we get is x, and this is cancelled, so here we get tan theta minus. Now if we simplify, we can write like this: minus g upon 2 v naught square cos square theta and x square. This is the equation we get. So I can simplify this, that I can say simply that this is the equation of the order of ax minus bx square, where a is equal to tan theta and b is equal to g over 2g by 2 v naught square cos square theta. Now if we analyze that a is constant and b is also constant, so we arrive on the conclusion that this is the equation where a is y is equal to ax minus bx square. This is the equation of a parabola. So a path traced by a projectile is the path of a parabola. Now at any time, I think I can write like this: at any time during the projectile motion, the velocity v can be given by this vx square, the x component of velocity, and the y component of the velocity. If we analyze that x component or the horizontal component was v naught cos theta square, and the y component was v naught sine theta minus gt square. All right. If you have doubt with this y component, then I think I can just scroll it up, and we can apply the same equation here in the vertical moment. the equation will be, just let me write here, v is equal to v naught plus at. So the velocity v is v naught sine theta, and a is minus g, and this is t. So this is the equation in this is the equation of velocity in vertical direction. So let me just rub this off, or we can use this value. So now the value of v can be simplified like this: under root v naught cos square theta plus v naught sine square theta plus g square t square minus 2 v naught gt sine theta. If we know that this is v naught square, and this is also v naught square. Now this v naught square, this is cos square theta plus sine square theta plus g square t square minus 2 v naught gt sine theta. So we know that the value of cos square theta plus sine square theta is equal to 1. So we can say v naught square plus g square t square minus 2 v naught gt sine theta. That is the value of velocity at any given time. And suppose it makes an angle of theta or angle phi. Suppose it makes angle phi with horizontal. So the angle phi, that is tan phi, can be written as vertical component of the velocity plus horizontal component of velocity is equal to v naught sine theta minus gt over v naught cos theta. We can simplify this equation further, and we can write. Now let's consider this particle, and this is a projectile which is started from O with a speed of v naught, goes here at maximum height, say A, and then reaches here at B. So the path traced by the projectile is O, A and B. Well, now let's find out time of flight. Time of flight. That means the time taken by the projectile while following the path O, A and B. We know that this is the initial velocity, which is v naught. So we can have two components, which is v naught cos theta and v naught sine theta. There are two components. I think I should write like this: v naught sine theta. Now let's write the equation of motion, which is S is equal to v naught t plus half a t square. This equation of motion let's write for vertical direction, for vertical motion. Now in vertical motion, what we have, S instead of S we can write y, and this becomes v naught sine theta t. Now the acceleration due to gravity is acting in downward direction, and the sign convention, this is minus sign and this is plus sign. This is the convention. The upward motion we are taking as plus sign, and the downward motion we are taking as minus sign. So here what we can write is minus half g and t square, where t is the time taken by the projectile while reaching at B. But we know it very well. The projectile starts from A and goes to B in vertical direction. The displacement of the projectile is 0. So here y is equal to 0. So we have this equation, that v naught sine theta into t minus half g t square is equal to 0. Or we take t common, we can write v naught sine theta minus half gt is equal to 0. So that means either t is equal to 0 or this fellow is 0. So we can write V naught sine theta minus half gt is equal to 0, or we can simplify it further. V naught sine theta is equal to half gt, or t is equal to 2 V naught sine theta upon g. So we can write that the time of flight t is equal to 2 V naught sine theta over g. So that is the time of flight. We can represent it with capital letter T. Now if we see, if it goes from O to A, this is called time of ascent. Here the projectile is rising, and here the projectile is coming down. So the time of ascent, like we can write here, the time O to A is equal to time A to B, and then we can write that this is nothing but half of t by 2, or simply we can write that V naught sine theta over g. Well, now let's work out and find out the maximum height attained. Maximum height attained, or we can call it as h. This is the maximum height attained. By the way, in this diagram, this is the height attained. So let's have the same equation where y is equal to v naught sine theta minus, we shall use the same equation, and we can write like this: y is equal to v naught sine theta t minus half gt square. Well, projectile was here, and it is ascending, and it goes here. So O to A, from this point to this point, this is the time taken by the projectile. That t will be equal to v naught sine theta over g, and y will be this height, which is h. So we can write like this: h is equal to v naught sine theta. The value of t is v naught sine theta over g minus half g, and t square again v naught sine theta over g square. If we simplify it further, we realize that this is v naught square and then sine square theta over g. And then if we see this term, this is also v naught square sine square theta into g, and here 2 and g square. So the 1g get cancelled, again is 2g. So if we simplify it further, v naught square sine square theta over 2g. That is the maximum height attained. Now we shall find out the horizontal range. Well, the horizontal range R. Now let's consider the horizontal motion. Actually, the particle or the projectile has moved from O to B, and if we consider this motion, this is the range R, although it has gone like this. So now let's figure it out. First of all, let me define the horizontal range. That this is the horizontal distance traveled by a projectile before returning to the ground. So again we shall use the same equation but in horizontal direction. So S is equal to V naught t plus half a t square. Now let me use this equation in horizontal direction. So S is equal to R, and this is V naught cos theta, and this is t, and in horizontal direction that means this is 0, so this term is 0. Now the time t is the total time of flight, which we have just computed here, which is 2 v naught sine theta over g. So let me just put the value here: v naught cos theta and then 2v sine theta over a g. That is the value of t. Now we simplify it further. V naught square, and then we have 2 sine theta cos theta over g. We can write it further, V naught square, and this is sine 2 theta over g. So that is R. So can you find out what will be the maximum value? Well, R max will be when this is equal to V square by g. That means sine 2 theta, that means sine 2 theta is equal to 1, which will happen then it is at 90 degrees. So 2 theta is equal to 90 degree, or theta is equal to 45 degree. So if the angle of projection here is 45 degree, the range will be maximum. The range will be maximum.